All right, let's do another example with parallel and perpendicular lines. Here we want to determine if the two lines that were given are parallel, perpendicular, or neither. Here we have the equations of two lines. They're not in very nice forms. But to determine whether they're parallel, perpendicular, or neither, we need to know their slopes. That means putting them in the slope-intercept form. The second equation, let's take that one first since it's going to involve less work. We have negative 2y minus x equals 9. Let's go ahead and put that in slope-intercept form. We have negative 2y minus x equals 9. We want to get y by itself. So let's add the x to both sides. So we'll have negative 2y on the left-hand side. And on the right, we have x plus 9. I guess that's the right and the left side. We'll divide by negative 2. And now we have y equals negative x over 2 minus 9 halves. All right, so the slope of this line is negative 1/2. Let's put that to the side here. Now let's find the line of, or the slope of the second line. So here we have 3x minus 3y equals, and we have x minus 1. Does not need parentheses. We have negative y, and then we'll distribute this negative into the negative x and get plus x. All right. On the right-hand side here, we can combine some like terms. So we have 3x minus 3y. X and x makes 2x minus 1 minus y. All right. Let's get the y's on one side and the x's on the other. So we'll add y to both sides. Clears the y from the right-hand side, and let's subtract 3x. All right, so this goes away. Negative 3y plus y is negative 2y. Here we have 2x minus 3x is minus x minus 1. All right, and now we'll divide by 2, negative 2. Y equals negative over negative is positive, so x over 2 plus 1/2. All right, so we have y equals mx plus b. The coefficient of the x here is 1/2, and so the slope of this line is 1/2. All right, slope of our first line is negative 1/2. Slope of the other line is 1/2. They happen to be opposites, but they're not reciprocals. So these lines are not parallel, they're not perpendicular, they're neither.